So you don't know me yet, so you might not trust me, but I'm going to ask you to do some things. It's always a good sign. Make some sound with your hands. Classic, we've got an audience. Everybody understands their role. That's good. Okay, now let's do a little exercise together. I'd like for you to check your posture. Just sit yourself up a little bit neater than you are. Just grab your shoulders and put them up to your ears and roll them back and just drop them. Ah, there we are. Yeah, that's what sitting up looks like. Good. So let's take 3 deep breaths in through our nose and out through our mouth, and we'll just see if we can't oxygenate our brains a little bit. Good. There we are. Good. So I'm going to have you put one hand out, doesn't matter which hand, and the other hand, let's do it this way. Do one hand right next to another, like you're going to clap. But instead of clapping, I'm going to have you put your hands together and just start to roll them slowly. And while you're doing it, listen. Now listen to your neighbors. And listen further away and see whether you can hear someone specific further away from you. Good. Okay, good stuff. So that's basically what my talk is about. I have an instinct to hit things, and then maybe if you touch them lightly, it's pretty. So I realized a lot of these talks had take-home messages, so I'm extending my talk by 30 seconds to just read you all the take-home messages now, so I don't have to worry about them in the context of the talk. Put pressure on the past to understand the future. What will happen if you decide to have artists invade your business and then you start listening to them? Pay attention to the energy between things. Remember that we are real bodies in real space. Slow down and breathe. So it's a great pleasure to be here, and it's my first time in Dublin, and it's been a really remarkable couple of days, and I'm excited to spend an extra day here after this is over to kind of understand the countryside. I've been in my role as artist-in-residence at Bell Labs now for 2 years, as of actually today. It's my 2-year anniversary at Bell Labs. I started on a 6-month residency, which for some reason they decided to extend for a year, and then this year we made the decision to go all in together, and so I'm there permanently in this role where I sort of interject myself in with the scientists. Dunal Hernan alluded a little bit to the EAT program, and today I'm going to dig a little bit deeper. I'll spend some time talking about my work while I was artist-in-residence for the official residency and my work now engaged in research with them. And then Levy Lorenzo from the International Contemporary Ensemble will join me to play an excerpt of my latest piece that sort of explores modifications of acoustic instruments. Oh, next slide, Seth. So what would one of the world's premier science research facilities find useful about art? And there's a bunch of corporate campuses that incorporate artists or artist-in-residence programs into their corporate architecture. And usually that takes the form of giving over technological assets to the artists, who then are very excited. They have free stuff to play with, they make a piece, and then they share it on Instagram, and everybody mutually benefits from the shared clicks and likes, and there's some added value of feeling as though it's a soft face for the corporate body. Bell Labs tries to do it a bit differently. They are aiming to fuse art and technology, as Dunal mentioned earlier. Some of this is an attempt to kind of push against the limits of our current modes of communication, because artwork challenges us. It pushes us to look a little closer at how humans communicate and look beyond accepted notions of what communication should occur. But also, and I think this is most important, my job at Bell Labs is to act as a kind of innovation wedge. I find myself digging out the weak links of unconsidered paths or ill-considered research and inserting a kind of divergent thinking into a linear thinking engineering process. And that has the effect of disrupting the R&D cycle. The other thing, and this is a little bit more personal, is that I'm the only person who's not on the senior leadership team, one of the only people who's on the senior leadership team, who has a lateral access to people across groups. So I'm in this weird plane that has no power, but lateral access across lots of different people. So I find myself connecting the dots in ways that don't normally get connected. But this is not new for Bell Labs. Bell Labs has been doing this for 90 years. At the beginning, in the late 20s, they made a tight connection with the Philadelphia Orchestra and Leopold Stokowski and did fundamental telecommunications research in the basement of Academy Hall in Philadelphia, where they invented the term hi-fi. They created high-fidelity audio there. They invented stereo recording there. And it was all because they wanted to be able to capture the entire range of the orchestra in volume and frequency response and transmit it over a telephone line. Because that was what fidelity meant at the time, and it was a 10x, 100x change in what was available in existing technology. They were the existing technology. In the late 50s, they made a computer sing for the first time. And that was part of a team, Max Matthews, Joan Miller, James Tenney, who were all musicians, who were technical staff members, who used their music knowledge to push computer synthesized speech forward. And then in the 60s, they made strides in computer graphics that are now part of the patent packages to design software throughout our ecosystem. They did a landmark presentation with John Cage, Robert Rauschenberg, Deborah Hay, and many, many others for a very famous art event called 9 Evenings. And today, this is my version of Dunal's slide, which has a bunch of the artists who we've been engaging with at the labs over the last 3 years. Projects ranging, one that's particularly interesting, Jeff Thompson up in the middle, trained a robot to touch the phone like he touches his phone. Touch your hand like he touches his phone. So when you put your hand out, it swipes and moves around as though it's a AI agent aware of what he had done, and the robot touches you the way he touches his phone. It's just a beautiful project. So before my position was made permanent, my residency year focused on what we have been describing as non-spoken or non-written language communication, or how sound or maybe haptics can play a role in addressing information that's lost or reinforcing an additional channel of communication. So we reached out to the International Contemporary Ensemble to imagine chamber music as a microcosm for human communication. These are people who sit in groups with one another, very tightly attached to their instruments that have 100-year-old practices associated with them, who've spent hours in the practice room becoming experts at expressing themselves through a particular set of gestures and eye movements and synchronized breath, to do a wordless thing with one another that generates something that's more than the sum of its parts, which is, for me, a beautiful metaphor for human communication. You imagine a group of people at a pub sitting around a table and talking with one another, and you can see a kind of invisible cloud of energy in the middle of the speech. And when it's good, when you're really connecting with another person, there's this heightened level of adrenaline and a back and forth with the conversation where there's a palpable energy in the air. And so how do you capture that palpable energy in the air and put some pressure on it, learn something about it? Well, it's hard to do it with the primary thing. It's hard to do it in the manifested way in speech. So we started to look at how it might be possible to do this in music. So I've been concentrating primarily on haptics. And remember, haptic feedback is built into instrumental music playing. So I thought if we could find a way to augment the touch feedback of instruments, it might give us some insight into the ways we can explore haptics in semantic language processes. So the hardest thing has been to think about how to bring this into my own practice. I'm a composer. I create concert works for the stage. I'm an artist working in AR/VR space, exhibiting works in galleries and installations. And I'm a scholar looking at the past to try to think a little bit about what the future might do. So in trying to create work that rethinks the relationship between the senses, technology, and society, we started to pursue a project where we were thinking about what might happen if we augmented instruments with 3D printed modifications to the instruments, or added additional sound sources to the instrument. So in the slide above, you've got a 3D printed loudspeaker with a speaker facing up and a speaker facing down. It's attached to the violin, and it's two speakers because the violin propagates sound in a very particular way. Sound comes off of the front head, or the front surface of the violin, and it has a full frequency range and a full amplitude response. And then on the back of the violin, it's maybe 30% less volume and a little bit different frequency response. So it's actually different. So I wrote a little filter coefficient that actually makes up the difference for those things. And when electronic sound come out of that loudspeaker that's attached to the violin, it propagates away from the violin in the same way that sound propagates off the violin when the player plays. So they feel connected to the electronic augmentation. The audience doesn't hear any difference between the electronic sounds and the violin in terms of the way that they engage with the space. If he moves, it moves with him. It propagates the way that you would expect. On the lower slide, Rebecca Heller, bassoonist for International Contemporary Ensemble, has a 3D printed loudspeaker insert in the bell joint of her bassoon. Now, bassoon is to be fancy, a 2.4 meter long conical bore instrument that when you play into the instrument, it sets the column of air in vibration. So what I decided to do was play the frequency that is the length of 2.4 meters, or a B flat, back down into the instrument with a nice rich overtone set. And it blossoms the inside of the instrument into this sort of acoustic open space that changes the nature of the acoustics of the inside of the instrument. So notes that would normally come out normal come out with alterations that are very subtle. If she opens and closes her hands while she's playing the bassoon, the finger openings and closing let little parts of the transduced sound from the loudspeaker come out the holes. And we even discovered that if you use that low B flat, you can train young bassoonists to figure out which part of the reed needs additional scraping in order to fix the tone of the instrument, because the reed vibrates against the lips because of the sound coming through the instrument and giving the performer additional feedback. So this is an example of her playing the piece. It'll last about a minute long. So those changes of tone are her lifting and closing her fingers while the tone plays through the instrument. In this last example I'll play before Levy joins me is a woodwind quartet that we wrote with some engineers at Bell Labs, where the woodwind quartet each has a 3D printed insert into the instrument, but this time, instead of playing the tone, an artificially generated synthesized tone back down into the instrument, we wanted to look at the way that the chamber musicians interacted with one another if the sound of someone else's instrument appeared inside their instrument. So while they're playing, there's a delay, and it's a calculated delay, but it's unpredictable. A little bit of slop in there so that no one can expect when it's coming. A flute player would play a tone, and then it shows up in the saxophone a minute later. And then the saxophonist would play a tone, and it would show up in the bass clarinet a little bit later. But on top of this, I wrote music that took into consideration the counterpoint of what would happen with the delayed tones plus the other tones plus the filtration of the instrument. And what you get is this little 1-minute excerpt of a 20-minute long piece. Pay attention to their eyes. and you can't hear that there's technology there, which is what I want. That it becomes seamless, that it's part of the system, that it's not trying to rethink what it means to be a wind quartet, but add technology in a way that enhances, enforces, reinforces what it's like to be a chamber musician performing with another body. So I'd like to take a second and introduce you to Levy Lorenzo, who's going to talk a little bit about International Contemporary Ensemble and how it fits into the EAT ecosystem.
Thank you, Seth.
Thank you.
Thanks so much. Thanks for having us. My background is in classical percussion and electrical and computer engineering. So while those two things may seem disconnected or not related, I try to find as many ways as I can to combine the two. And so I think about the embodiment of sound. That's something that I'm obsessed with. And as a percussion performer, actively using my hands to make sound, that then informs my decision as a software engineer or a circuit designer. So in terms of the embodiment of sound with acoustic instruments, the flute or a bassoon that we saw in the film, and also with the snare drum, it's very connected. It's sort of a Newtonian conservation of energy, where if I blow hard or I strike, then that is a connection to my action. But with electronics, there is this disconnect. Really any human gesture to any sensor, for example, a button. If I press a button, it can be any sound. So that question of mapping is the question that I ask myself every day. So how can I connect my body as a physical performer to this electronic sound? So in the International Contemporary Ensemble, I have several roles, and I'm very happy to be working with these colleagues and creative musicians and cultivators of this art. So I work as the technical director, so leading projects, solving the problems of bringing electronic sounds onto stage along with acoustic instruments. I'm also their percussionist and sound engineer, and whenever anything has to come out of speakers or to be made with circuits or code, I'm responsible for that. It's sort of a new position that's coming up, that's emerged as a classical musician, the one that incorporates electronics and computers into a concert stage. So we have been lucky to be in residence with Nokia Bell Labs in their experiments art and technology department. And their mission, as we saw Dunal explain about a half hour ago, to explore how technology can communicate empathy, how technology can communicate musical emotion. So the work that we're doing in doing experiments and developing new work, commissioning composers, playing live concerts, and making new devices that we can physically interact with as humans, and also that you all can watch us physically hold and touch and squeeze and press and pluck, that's so interesting to me. So Seth and I have been working on one of his newest pieces with a snare drum.
It's true. And I didn't want him to hit it.
Okay.
So I spent some time thinking about the membrane of the drum head. What is the thing that excites it? And striking a drum is the thing that excites the drum. So excitation being the physics term for getting sound out of a surface, right? Marching bands and the like. For me, I wanted to see what happens if I take all of the normal modes of vibration that happen whenever a strike happens and feed it back into the instrument very slowly in a way that allows the instrument's surface to be responsive. So it's using the sound of the snare drum to give Levy a new kind of a body to engage with as a percussionist, where he places his hands, where he moves his hands changes or alters the tones that get played. So let's take just a second and we'll play just a sample so that you can hear what's going to happen, so that when he performs you know what's going on. So we're not hiding anything from you. No secrets. There's no secrets between us. We're good with this, yeah. Good. Okay. So there's no active processes happening, no software that's adapting to his playing. It's just tones chosen correctly, exciting the instrument and giving him a surface. And over the course of the piece, we change the tone. So we'll play this, and then that will bring our talk to a conclusion. Levy Lorenzo. Thank you very much.